Hey YouTube, this is Jay Kilroy again. We have a little project, another little project. This is kind of a common problem. What we have here is a DC gear motor by a company called Gearmotor Shaft, American company. Top quality product here. This right here on the end here is an Italian gearbox. It's made by a company called Transecto. Real modern, ultra modern, die-cast aluminum design, little worm gear. This is a 5-to-1 gearbox, right angle gearbox. And then we have the supplied sprocket. This is a stainless steel, it's a Browning part, 9-tooth, number 35 chain, 3/8 inch bore. I used to be able to buy these with a plain bore or unfinished bore. I really wish I still could. If anybody knows where I can buy Browning sprockets like this with an unfinished bore, let me know. This little jewel right here is about 60 bucks, right? So what's the problem? What's the job here besides building the shaft? The job is, this is a metric gearbox and this is a imperial sprocket. So we've got a 12mm shaft with a 1/8 inch key. That's nice touch, right? With a 3/8 inch bore sprocket with a 3/32 key. And we've got to do a shaft to go through this gearbox. We've got to do a, we could do a snap ring back here, but I prefer just do a boss on the back side. Snap rings can come off. It's rare, but it does happen. So I prefer just do a little OD, a little oversized OD here to hold it in the back side. Then there will be a couple of diameters coming through, a groove for the key, a snap ring on this side to keep the shaft to a limit in play here. Then there'll be another diameter for a 3/8 diameter for this sprocket, and then the little bitty micro key that I hate milling, and a set screw flat or two, and we should be in business. But the drawing, the customer was nice enough to supply a drawing that came with the gearbox. It was the wrong drawing, unfortunately. So gonna have to do my own. I've looked around on the website. Spent quite a bit of time trying to Google this thing up and find a drawing, but no luck. So gonna have to do a little drawing to get us going here. And let's talk about drawings for just a second. I know a lot of people, if you're doing hobby work, you're doing your own work, and you're sketching stuff out on napkins, that's great. But if you're a serious hobbyist, which really I just really qualify as a serious hobbyist, I do all sorts of work professionally. But if you're a serious hobbyist and you find yourself doing work for money, let's be clear, you need drawings. And what you need to do is you need to produce drawings before you produce parts. And your customer needs to okay the drawings. This is just, we live in CYA land, so put a little armor on your hind end, produce a drawing up front, and have your customer okay the drawing, and then produce your part to fit the spec, and then you're good. Then you're going to get paid, right? You just don't want any confusion, any misunderstanding between what's been contracted for and what's been provided. Good communication is the key to good business. And so you don't see a lot of this on YouTube. You see a lot of metal cutting, which is neat and fun, and you see a lot of welding, and you see a lot of beads, but people don't talk about the business side of business, and that's how you can get yourself in big trouble. So I've coined a new phrase a couple of videos ago. You want better parts, make better drawings. So good drawings make good parts, I guess, is the corollary. Good drawings and good contracts are like good fences. They make good neighbors. So we're going to produce a drawing for this part. Alright, YouTube, if you're following along, we did our drawing. See, here you go. The shaft we're going to make here, went through the drawing process. And then I've got a chunk of stainless here. I believe it's a chunk of 416. This is left over from gosh knows what. This is what we're going to make it out of. 416 is a fairly easy to machine stainless, and one that I like to use on a regular basis. 303 is also a 303 is another favorite. I just noticed that this center drill is toast. Check that out. That baby is flat rounded over. Let me grab another one here real quick. This one's a little smaller. This is a number 3. I must admit, I've got some, for center drills, I've got some chintzy ass import tooling that don't last real long. If there ever was a piece of tooling that goes away real quickly if you don't buy quality, it's center drills. So I'm going to go ahead and fire this thing up, and pardon the noise, I'll dim it in the video. We're going to go ahead and center drill this, get a center in here, get the stock pulled out, and go ahead and start roughing it down. This is some 3/4 inch material. We're going to rough down to an OD of 5/8 for our flange on the drawing there, the bottommost feature, and we're going to work out this way. I'm a big fan of the cutting lube. That's some clear sulfurized cutting oil. It's basically just the clear version of the dark stuff that you're used to. The big advantage of the clear is you can use it on material that would otherwise be stained by the dark stuff. Some brass and bronzes, coppers will stain pretty readily from dark cutting oil, and the clear stuff will not. Center in here. Whew. Lathe we're using here is a Rivet 1020F of approximately 1968 vintage. It's actually the latest serial number I've ever seen. Pretty nifty machine. This one needs a little work. I got a couple bearings I need to replace and a half shaft, and got to either replace do the bushings in the Reeves drive. You can hear the noise. So here we are. We've got our material in here. So this material Mic's out to 748, and we're going down to 625, so we got a little cutting to do. And let me get a little more room here. Alrighty. This is the ubiquitous diamond tool holder we're using here. Got a piece of T15. Let me adjust my camera angle up here a little bit. We got a little piece of T15 tool steel in here, and we're going to go ahead and get this baby fired up and go ahead and take some cuts. Let's take a quick read. Okay, 646. We're most of the way down to our 625. So we need to come down about 20 more thou to hit our 625 dimension. So let's crank it back up here. Dial us in about 20. Alright, so my card filled up there. We got down to our 5/8 dimension here. We need to carve back to our 12mm dimension now, which is a little over 1/8 of an inch to take off. So we're going to go ahead and hit it. I'm going to do a quick 0 on my dial. I don't know if you can see that. I'm going to 0 my dial at my current location. I've calculated out I got to take off down a little over, like I said, a little over 1/8 of an inch, about 140. So we're going to go from there. Still having more camera problems. Let's see. Alrighty. That's 40. Let's come down another 40. Alright, let's get a quick check on our diameter. Alright, we're at about over a ½ inch even. We're going down to 0.471. So we got about a millimeter to take off. Oh, 25 thou. Okay, we're getting right down to it, so let's check a little more often. So yeah, we're at 478 or 12.09 millimeters. So we only really need to take off about 7 thou or so to hit our target dimension. So actually all I'm going to do right now is take a little spring cut. I'm just going to make a pass across here, not going to advance it at all, and we're going to go with that. I bet you we're getting pretty darn close here. A nice finish there. For our purposes, this is fine. Right, so we're still a little high. I'm just trying to sneak up on it. We're still just a little high. Still about 3 thou high. So we're going to have to take one more cut. Alright, we're going to mark out here, and that's my first dimension, 883. My next dimension is 163. There we go. My next dimension is 2 1/8. snap ring groove. And my next dimension is 231. That's my 375 dimension down here. So we've laid out the location where our slot is going to be and our recess. We laid out the location of our snap ring. The snap ring goes to the right of this line, and then we laid out the border for the 374 dimension for the sprocket that goes right here. So what we're going to do first is the sprocket. A little cleaning. Get our center back in place. Right. Get a measurement here. Take off about 118. So let's fire it up and get with it. Checking up. Right. We are getting close. We're running about 395 there. We need to come down to 374, so we got about 21 to take off. Okay. Let's see what we got here. Oh yeah. So let's back this out again. The mating part is the best gauge ever made. Let's try that out. Right on the money. So we need to go ahead and get our snap ring groove in here, and then cut our relief along the key. Put a little bevel across the front, and then we'll be ready to part off and move over to the mill. Alright, we're going to go ahead and cut our relief here. This is not a super scientific process. If your key slot gets a little bunged up on the corners, you can still get the shaft out of the gearbox. If you leave it flush with your diameter, with your OD, and then the key moves around a little bit, or the material's not that hard, you're gonna pay hell getting the shaft out and possibly damage the ID of your gearbox, and that's not something you want to do. Alright, we're going to mount up our grooving cutter here. If you cut a lot of O-ring or snap ring grooves, it pays to invest in a quality inserted grooving system. I have several. This is a brand Nicole, N-I-K-C-O-L-E, from Mini Systems, and you can see right off the bat my center height is way off. And it's a serious time saver. Scale out. Get the center height here. If you don't know the scale trick, you reduce your center height until the scale is vertical, and you're on center, like so. This is an omni-post tool post, largest size they make. Anyway, we're good there. We're going to go ahead and cut this groove. I'm going to set 0. This is the snap ring takes an 029 groove. This is an 031, 31 thou groove that we're cutting. And according to the drawing, there we go, 029. There we go, we got our snap ring groove, and now we just need to get this baby out of here and head to the mill. Okay guys, we are through with our parting disaster. Got our part here mounted, ready to cut the 4mm key in a 5C, 15-30 seconds 5C collet, which suffices in a little hard hinge 5C index. You hear this just gripped in the vise. We got to find center first, and we could get out the the edge finder and do it that way, but we're going to do it kind of a quick and easy way, and let me show you how to do that. So what we've got here is this, I'm sure you've seen them, bump to the camera there. May have to raise the table a little bit. Yes, I am going to have to raise the table. Just one touch. Adjust the camera up a little bit. What we've got here is one of these little chintzy center finders that actually does a pretty good job. You just mount the thing in the collet, roll it over until it lines up, and voila, you are good to go. Now, the cutting tool we're going to be using is a 4mm end mill, as you might expect for 4mm collet. It's a 4mm solid carbide end mill with a 6mm shank, made by Niagara Cutter. Some kind of coating, for this purpose it doesn't really matter. And we're going to hold it here in a 5/32 collet, which is a nice firm fit. Alright, I had to change my work holding up here because my the spindle nose was touching the collet holder before I could make the full length of cut. So I've changed my collet out to a 3/4 and grab the stub end down here. Again, as minimal as the cutting forces are with a 4mm end mill, it's not something we have to terribly worry about. So the first thing I'm going to do here is I'm going to zero out my quill DRO on the full diameter. 0. I'm going to change it over to millimeter scale, and I'm going to fire it up. Alright, we've got a 4mm wide slot cut there to a depth of 2.07 millimeters. That should work well with our setup. Now we are going to feed out here, and we're going to cut our 3/32 key slot here 90 degrees off of this, and then we'll go 90 degrees back from that, and we'll cut a set screw flat. Alright, I got my 1/8 inch end mill mounted here. It's an 1/8 inch collet. It's a 3/32 end mill, and I really don't like these little tiny things. I realize I have a lot of hangout here, but I'm taking a little micro cut. Got plenty of rigidity in the setup for this teensy little bitty cut. So I'm going to go ahead, and I've zeroed out my quill on the surface. I need to take a 1.5 30-second cut for a square key, which is 0.046 is what I need to take, micro key. So I'm going to go ahead and fire it up. I'm going to just feed down about half of that, probably about 20 thou, take a cut all the way full length, and then I'm going to go back and then take the rest of it here, and I'm going to feed it real slow. Okay, I know that was excruciatingly slow. But I do not have a power feed on this mill. That is a future project for sure. We got that little dinky, tiny 3/32 slot cut without busting the end off an end mill, which is a miracle, for me at least. And now we are going to, we've indexed around 90 degrees, and now we're going to touch off, and then we're going to cut a very small set screw flat. We are done here. We are assembled. I have my key, my 4mm key in here. I buy all my keys oversized so that the keys are a file fit. And then we're going to slip on the snap ring. There we go. And then have my 5/32 key here. There was a burr down in this sprocket where they broached it, and that was somewhat of a real pain in the butt to get taken care of. And so here we go. There we go. So we did a drawing, we did a part. I actually think you know, machining with the video camera watching you is like working with someone looking over your shoulder. It really is a lot slower. But this is a typical, do quite a few of these, and like I said, it's just a little detail item. So you've got, here are some old ones here, I've got some other ones sitting here. The gearbox has changed over time, so this is a 12mm shaft with a 1/2" bore pulley, and then this is back when they used to actually sell the shafts with them. Again, 12mm shaft, see the snap ring on the back side, and then a 1/2" bore shaft with a 1/2" bore pulley. This is a much larger pulley. What is this here? It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a 12-tooth sprocket, which really is too big for this application. So these are kind of some of the the life cycle of these parts, and the most recent here, 12mm bore and a 3/8 ID pulley. Again, if I could find these Browning pulleys, if anybody knows where to get these Browning pulleys with an unfinished bore again, let me know. I got this one at Master Car. They used to sell the unfinished bore, but they don't show it on the website anymore. So any pointers where to get the unfinished bores, I'd appreciate it. Anyway, we got some more projects coming up, and some pretty big ones, so stay tuned. Be safe in the shop. Bye.